Hi everyone, welcome to our channel EE Education. Today we are diving into the fascinating world of electrical engineering. Focusing on network elements, we will cover resistors, inductors, capacitors, mutual inductance and different types of sources. By the end of this video, you will have a solid understanding of these fundamental components. Let's get started. First, resistors symbolized by the letter R. A resistor in an electrical component that limits is an electrical component that limits and regulates the flow of electric current in the circuit. Ohm's law, which is V is equals to IR, is demonstrated using this diagram. It relates V is equals to IR relates the voltage V across resistor R to the current I flowing through it and its resistance R. For example, if we have a 5 ohm resistance in a circuit and a current of 2 ampere flows through it, then the voltage across the resistor would be 5 ohm into 2 ampere, which is equals to 10 volt. Then we are coming back to our next component, inductor L, symbolized by letter L, demonstrated by this symbol. The inductors store energy in a magnetic field when electrical current flows through them. The voltage across an inductor is given by V is equals to L di by dt, where L is an inductance and di by dt is the rate of change of current. Inductors are often made by coiling a wire. The inductance depends on the factors like the number of coils and the core material. Then capacitors are symbolized by the capital letter C. Stores energy in an electric field. They consist of two conductive plates separated by an insulator. The voltage across capacitor is related to charge Q by Q is equals to CV, where Q is an charge and C is the capacitance. These following graphs are showing the capacitor charging and discharging. In AC circuits, capacitors oppose the changes in voltage, leading to a phase difference between voltage and current. This property is crucial in filtering applications. Mutual inductance. Next is our mutual inductance, symbolized by capital M. Mutual inductance occurs when two inductors are placed close together and the magnetic field of one induces a voltage in the other. The mutual inductance M is given by V2 is equals to M di1 by dt. di1 shows the partial amount of current flowing through L1. This principle is used in transformers where energy is transferred between circuits through a shared magnetic field. In this way, I1 is the current flowing through the L1 and I2 is the current flowing through L2. Now our second topic of the today's discussion is ideal voltage and current sources. So ideal current source, ideal voltage source provides a constant voltage regardless of the current drawn from it. So it is represented by a circuit with a plus and minus sign. Now ideal current source. Dependent sources conversely, an ideal current source supplies a constant current regardless of the voltage across it. It is depicted as a circle with an arrow inside. Now we are coming to our last point of the today's discussion, which is dependent sources. Dependent sources are controlled by another voltage or current in the circuit. There are the four types of controlled voltages. They are voltage controlled voltage source. We can see here voltage is controlled by a voltage source VCVS. Here current controlled voltage source, where voltage source is controlled by a current flowing through another circuit. Then voltage controlled current source, we can see here the current source is controlled by the voltage flowing in this circuit. Then last one is current controlled current source, where a current source is controlled by a current flowing through another circuit, which is CCCS. To summarize, we have covered resistors, capacitors, inductors, mutual inductance, and both ideal voltage source and ideal current source. These components are the building blocks of the electrical circuits. We have also covered the dependent sources. So understanding them is crucial for analyzing and designing circuits. Thank you for watching. Don't forget to like, subscribe and hit the bell icon for more educational videos. Leave your questions in the comments below and we will see you in the next video. Happy learning!